So in this class we are discussing about the one more transformation, that is W is equal to Z plus A squared by Z. Now for our convenience, in order to arrive at a proper result, you may substitute Z is equal to X plus IY, W is equal to U plus IV, or W is equal to U plus IV, Z is equal to RE to the power I theta, as you like. So therefore let us start like this. Let us substitute W is equal to U plus IV here. Wherever Z is there, for this Z, let us substitute R into e to the power I theta. If I substitute, what happens? W is equal to U plus IV. I have written here. This W is equal to U plus IV. Now Z, R e to the power I theta. Because any complex number Z, it can be represented in two forms. One is X plus IY. Another one is R into e to the power I theta. Remember, any complex number Z, either it can be represented as X plus IY, right? Or it can be represented as Z is equal to R into e to the power I theta. So therefore what I am doing, wherever W is there, for this W, I am substituting U plus IV. Wherever Z is there, for Z, R e to the power I theta, plus A squared, I have written A squared as it is, divided by Z, for this Z, R e to the power I theta. So therefore from this R e to the power I theta, first term write that as it is, A squared written as it is, A squared by R, write that as it is. So what is remaining? 1 by e to the power I theta, take it to the numerator, e to the power minus I theta. This is A squared by R, written as it is, e to the power I theta is there, take it to numerator, that becomes e to the power minus I theta. Now use the formula, e to the power I theta, f and e to the power minus I theta. What is e to the power I theta? E to the power I theta is, observe, cos theta plus I sin theta. E to the power minus I theta, cos theta minus I sin theta. This is the formula. So therefore here I am substituting. These are written as it is. E to the power I theta, cos theta plus I sin theta. A squared by R, written as it is. E to the power minus I theta, it is written as cos theta minus I sin theta. Now what I am doing, I have to separate the, as usual, I have to separate the real and imaginary parts. So therefore here in the real parts, what is the real part? R cos theta, because this is not having I. What is the real part here? A squared by R into cos theta. It is not having I. Now, you take cos theta as common factor. If I take cos theta as common factor, what remains? R. I have written. Observe in this term. If I take cos theta as common factor, R remains. Here, in this first term, if I take cos theta as common factor, what remains? A squared by R. I have written that. Next, in the imaginary part, what is the imaginary part? I sin theta. Here, what is the imaginary part? Minus I sin theta. Right? So, in the imaginary part, if I take I sin theta as common factor, I sin theta if I remove 1, that 1 multiplied to R. If I remove I sin theta as common factor, what is the number behind I sin theta? 1. That 1 multiplied to R, I have written. Next, here if I remove I sin theta, what is remaining? Minus 1. If I remove I sin theta, right? What is remaining? Minus 1. That minus 1 into A squared by R, I have written that minus 1. So what I did? Take cos theta as common factor, you will get this much. Take sin theta as common factor, I sin theta as common factor, you will get this. So therefore what is the real part? U is equal to, what is the real part? The expression which is not having I, cos theta into R plus A squared by R. Next, what is the imaginary part? Coefficient of I, V, I have written that is equal to. Here what is coefficient of I? Sin theta into R minus A squared by R. Remember, whenever cos theta and sin theta comes, always we are using the property cos squared theta plus sin squared theta is equal to 1. So therefore, from 1, you find the value of cos theta. From this equation 1, find the value of cos theta. What is cos theta? Cos theta is equal to U divided by R plus A squared by R. I have written the same here. From this equation 1. What is cos theta? U by R plus A squared by R. What is cos theta here? Observe, cos theta is equal to, observe, U, this U divided by R plus A squared by R. Now, from equation 2, this equation 2, what is sin theta? Sin theta is equal to V divided by R minus A squared by R. From equation 2, what is sin theta? Sin theta is equal to V divided by R minus A squared by R. Now, so I have calculated what is cos theta, I have calculated what is sin theta. Now let us square this cos squared theta. Cos squared theta means U square, squaring this. Cos squared theta means U square. Here R plus A squared by R whole square. Sin squared theta means v squared divided by r minus a squared by r whole square. Same thing. Cos squared theta plus sin squared theta is equal to 1. Cos squared theta means this you are squaring, right? U by r plus a squared by r whole square. I have written that. Sin squared theta, right? Sin squared theta is here. Sin theta is v by r minus a squared by r. Square this. V squared by r minus a squared by r whole square is equal to 1. This is what I am having. Now observe. Suppose if I substitute r is equal to some constant. I shall tell you in the next what is r is equal to k. First let us assume r is some number. A is already some number. When r is a number, a is some number, r plus a squared by r is some number, that number whole square, let us call that as a square. Similarly, when r is a number, r minus a squared by r is some other number b, so therefore this you will get b square. So if I take r is equal to some number k, that is constant, when r is equal to constant, this denominator is a square, this denominator is b square. That is probably what I have written here. Now, so when r is equal to k, that expression it has become u squared by a squared plus v squared by b squared is equal to 1. Let us understand what do you mean by, right, r is equal to k. R is equal to k means what? What are the variables? R and theta, xy. Xy plane, x and y are the variables. In the r theta plane, what are the variables? R and theta. Now what I am taking, r is equal to k, isn't it? What I have done here, observe, here I have substituted r is equal to k. When r is equal to k, this denominator is a square, this denominator is b square. So u squared by a squared plus v squared by b squared is equal to 1 you are getting. So r is equal to k means, observe, here r is equal to k, that is say 10 centimeter, it is fixed. I cannot take once again that as r is equal to 11 or 15. R is not varying, r is equal to 10 is fixed. But another variable theta can vary. That means this radius, it can be rotated. When it is rotated, what happens? It is a circle. So r is equal to k means the radius r is fixed. That means theta can vary. That means when theta can vary means you are getting a circle. So therefore, if I take r is equal to k, that means when I take a circle in that plane, what we are getting? We are getting u squared by a squared plus v squared by b squared is equal to 1. That means what? This is an ellipse in the UV plane with focus. This is an ellipse in the UV plane with focus plus or minus 2a 0. Right? Now, let us go to the another one. You already know what is equation 1 here. Equation 1 is cos theta into r plus a squared by r. I have written that. V is equal to sin theta into r minus a squared by r. That is equation 2. Same thing I have written here. Observe. This is my equation 1 here, isn't it? This is equation 2. Now from this equation 1, let us find u by cos theta. From this equation 1, divide by cos theta, u by cos theta. Cos theta by cos theta cancels. So what remains? R plus a squared by r. So from this, divide by cos theta, u by cos theta. Cos theta by cos theta, 1. R plus a squared by r. That is what I have written. Similarly, from this equation, divide by, in equation 2, divide by sin theta, v by sin theta. Divide by sin theta, v by sin theta is equal to sin theta by sin theta, 1. R minus a squared by r. So what you got? U by cos theta is this, v by sin theta is this. Square this, u by cos theta whole square. Here also is square, v by sin theta whole square. Subtract. Observe the point. Square this, u by cos theta whole square. That means r plus a squared by r whole square. That's what I have written. R plus a squared by r whole square. U by cos theta whole squared means r plus a squared by r whole square. I have written that. Minus, I have written. V by sin theta. This v by sin theta whole square means r minus a squared by r whole square. I have written it here. Now when I simplify this RHS, you are getting 4a square. Now divide both sides by 4a square. When I divide by 4a square, this becomes 4a squared into this. Here also divide by 4a squared into this, 4a squared by 4a squared 1. That is what I have, 4a squared into this. Now suppose if I substitute theta is equal to k, if I substitute theta is equal to k. Suppose theta is pi by 4. Then what is cos pi by 4? You know the value. Cos pi by 4 is 1. That means it becomes a number. So when theta is a constant, this is a number. And this is 4a square. When theta is a constant k, this will be 4a squared into k squared. When theta is equal to k, 4a squared into. So let us call this total constant by some other name a squared. This total constant by some other name v squared. So what you are getting? When theta is equal to k, u squared by a squared minus v squared by v squared is equal to 1. Let us understand the meaning of what is theta is equal to k. What is theta is equal to k means what are the variables we have? R and theta. Theta is fixed. That means this radius whatever is there, it should not rotate. It is not allowed to rotate because theta is fixed. Since theta is fixed, it is not allowed to rotate. R can vary. R can vary like this. So R can vary like this means when I take a straight line, theta is fixed. You cannot rotate. So it will not be a circle or some other shape. Since theta is fixed, this straight line, it cannot be rotated. So therefore it will remain as a straight line. So therefore the thing is this, when theta is equal to k, that means angle is fixed, R can vary, that is a straight line passing through the origin. If I take a straight line passing through the origin, it gets transformed into a hyperbola in the UV plane. Why? Because observe the equation. What is this equation? U squared by a squared minus v squared by b squared is equal to 1. What is this? This is a hyperbola. When you are getting a hyperbola? When theta is equal to k. When theta is equal to k, you are getting a hyperbola. So therefore, the explanation is like this. When theta is equal to k, that means when I take a straight line passing through the origin, it gets transformed to a hyperbola. So this is the straight line. Observe, this is the straight line I have taken. This straight line is transformed to this hyperbola like this. When I take a circle, this circle, in the first case, when I take a circle, it gets transformed into an ellipse with focus to A0. Okay, let us stop at this.